The video Thermodynamics and the End of the Universe explained how, according to the second law of thermodynamics, all life in the universe will eventually end. However, after watching, many people have written comments questioning whether or not the second law of thermodynamics is actually a fundamental law of physics. For example, the second law of thermodynamics states that this event can never occur. However, many people have commented that although the probability of all the balls gathering back together in just one area of the box is very low, the probability is not zero. Therefore, some people have argued that the second law of thermodynamics is not a fundamental physical law due to the fact that it can theoretically be violated. Other people have argued that the second law of thermodynamics is not a fundamental physical law for a very different reason. They commented that even if we had never heard of the second law of thermodynamics, we would still be able to calculate the future paths of these balls just by using the other laws of physics, such as Newton's laws of motion. Therefore, they argue that the second law of thermodynamics is not a fundamental law because it does not say anything new about the universe that was not already implicit in the other laws of physics. Unfortunately, it turns out that neither of these arguments are valid. To the best of our knowledge, the second law of thermodynamics is a fundamental law of the universe, and one of the most important ones.
Entropy is surely one of the most intriguing and misunderstood concepts in all of physics. The entropy of the universe must always increase. So says the second law of thermodynamics. It's a law that seems emergent from deeper laws. It's statistical in nature, and yet may ultimately be more fundamental and unavoidable than any other law in physics. Einstein said that the thermodynamics that encapsulates the second law is the only physical theory of universal content which I am convinced will never be overthrown. And the great astrophysicist Sir Arthur Eddington warned, "If your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for it but to collapse in deepest humiliation." We've looked at entropy in the past.
Conceptual advances. My lectures are about three related conflicts of principle. I think it's fair to say that all have powerfully changed physics, even though not one of them has been completely resolved. Today, I will discuss Boltzmann's struggle with the second law of thermodynamics. On the one hand, entropy always increases. On the other hand, Newton's laws are reversible. We will come to what that means. The outcome of the struggle was profound. Entropy is hidden information. Boltzmann's insight deeply affected every area of science, but in the end, it did not solve the problem that Boltzmann originally set out to conquer. Why is there an arrow of time? Why does time go one way? What's different about the future than the past? I'm going to explain how modern developments in cosmology make this puzzle even more puzzling, and how they also suggest a solution. But be prepared to be very skeptical. We'll be driven to extremely remote ranges of time and space, way beyond anything we can hope to directly access. Nevertheless, The arrow of time is a fact of nature and deserves an explanation. So let me begin. I will just comment that I think it's an absolute disgrace that a beautiful, wonderful room like this in which physics can be presented does not have a permanent blackboard. Had I known that when
that man is the product of causes which had no provision of the end they were achieving, that his origin, his growth, his hopes and fears, his loves and his beliefs are but the outcome of accidental collocations of atoms, that no fire, no heroism, no intensity of thought and feeling can preserve an individual life beyond the grave, that all the labors of all the ages, all the devotion, all the inspiration, all the noonday brightness of human genius are destined to extinction in the vast death of the solar system, and that the whole temple of man's achievement must inevitably be buried beneath the debris of a universe in all these things, if not quite beyond dispute, are yet so nearly certain that no philosophy which rejects them can hope to stand.